Hi Twitch, and welcome back. We're live from the AWS Summit here in New York on the eastern seaboard of the United States of America. I can say that because I'm British, of course. And I'm delighted to be, I'm Ian, by the way, Ian Massingham from the AWS Evangelism team. I'm delighted to be joined for this next segment for another feature where we're going to be talking a little bit more about AI and machine learning using Amazon Web Services services. And I'm joined by some special guests. I'd like, first of all, to ask you all to introduce yourselves, maybe talk a little bit about the organizations that you're from, and also explain who you are and what your role is there. So let's kick off.
Kelly? Sure, I'm Kelly Dyer, founder and CEO of SourceFuse. We're an advanced consulting partner with Amazon. We help bring the startup culture to enterprises and come in and find big problems to solve, and how we leverage new technology to do that. And obviously AWS and other microservices and components are a big part of that. We just try and bring the agile environment, rapid release to large companies with big problems.
Great.
Hi, I'm Kabir. I'm the Chief Operating Officer of SourceFuse Technologies. I pretty much look after delivery, work very closely with Kelly and all the clients, trying to figure out which best of class sort of solutions out there that we can really use to solve real world problems.
So my name is Niranjan Hira. I'm a solutions architect on the Amazon Lex service team. And my job is sort of in between the product side, where we collect feedback from customers, and the technology solutioning side, where I help customers put these services together for their solutions.
Great, and we just used another AWS service name there, which probably a lot of people on the stream are not familiar with. So Amazon Lex is a service that Amazon Web Services created to help our customers build intelligent chatbots. So it's capable of natural language understanding, intent resolution, entity extraction, all of the other service components that you need to build intelligent chatbots that behave like human beings in understanding the needs and wants of users, but are actually software at the back end. It's actually one of my favorite AWS services, so I'm stoked to have a segment about this to host here on twitch.tv/AWS. It's something that I work with a lot myself. So the first thing that I want to do is just ask the team from SourceFuse. You're obviously going to bring a customer case to talk to us about today. So what is the customer problem that you were trying to solve with this particular solution that you've built, and what kind of customer are you providing it to?
Sure, yeah, the one we're talking about today is in the healthcare domain. They're a large company, about 1.6 billion, the market leader in workers' compensation claims management. So a lot of logistics and handling, and it covers transportation, physical therapy, language and translation, which are all common challenges in the workers' comp and injury and healthcare claims management space. So they're very large, market leader by a long way, and they kind of the ones we focus on this use case is specifically translation or transportation and language, and how we interact and deliver on those claims. So, you know, it's a big market of $6 billion, I think, in healthcare costs of missed appointments. You know, you can have the best healthcare in the world at a clinic, but if the patient doesn't get to the appointment, it's all for nothing. And there's a lot of cost from just missed appointments in general, and so that's where OneCall comes in and makes sure everyone gets there on time, all the claims are handled, all the logistics around that are delivered smoothly. And so that's what we came in to help. It's largely been a human-driven interaction, call center-based, which obviously has its own efficiency problems. So we came in and built a tool that can handle real-time delivery, real-time visibility. You know, we integrated with Lyft, as well as they have an internal driver network where you can really monitor in real time, so agents can see all the rides going off. We can track and manage variance on if late to appointment, on time to appointment. We can apply smarts to how those happen and how they get routed. We can they can pick up issues and alerts and handle them manually, but what would be a large number of people in a call center is now a few people on a dashboard to handle the whole logistics of what they do, so a big gains through technology.
Can we just take a second to get the feed from here so we can show people what the situation looks like before their solution was put in place?
Sure, let's do that, yeah. So let's switch to the laptop, please, production team, and let's take a look at the architecture that's been built here.
So if you want to talk to this slide, what people are seeing is right there.
So yeah, for the system itself, Kabir, you want to go through the...
Yeah, I mean, so like Kelly said, so what we built is a system for OneCall, which is like the eye in the sky, which basically helps agents orchestrate and facilitate rides. So essentially what we're looking at is favorable patient outcome, right? We want the patients to get well faster, get back to work, favorable health outcome. So one of the main drivers for that was them not getting on time. And what we built was really an omni-channel solution, right? So you don't want to let a particular demographic sort of out of focus from getting value from your product. So,
but one of the things that when you started out with it, right, you had built essentially an app and a whole bunch of other things.
Sure.
And one of the things that you discovered as you were working with real customers, getting the data of usage, is you found something interesting. So what did you discover?
Yeah, I mean, everyone knows, apps have an adoption problem. So we primarily relied on, vanilla SMS texts to let patients know that, their appointments have been booked, the driver's outside the house, that you, 20 minutes prior, be ready, so-and-so is coming in a lift, red colored car, blah, blah. So, really getting rid of any sort of anxiety that the patient might have of not being able to get to their appointment on time, which works great, at least for, 80 to 90% of the time. So what we did was, we have a large sort of database where we sort of audit log everything or what's happening. And when we started digging into why some patients either never got to the appointment on time or were late, what we discovered that they never got the SMS. And they never got the SMS because, believe it or not, 50.2% of US households still are non-wireless households. They still have landline phones. So all of these people were actually registered on the service with landline phones, which means they never got the SMS, which means the taxi could have been outside their house, for 10, 20, 30 minutes, and they never got to their appointment on time, which is why, we had to come up with a solution.
So let's talk about that new offering then, right? So you used the data science that you had, you used the access that you had, you discovered this challenge, and one of the things that I really like about the solution is you didn't say it's not AI enough, it's not cool enough, right? You just said, here's the problem, right? I'm going to go after it with this solution. So let's describe that solution for people.
Sure, I mean, it's an amazing solution because it uses something as high tech as AI and ML that AWS has democratized so well. But it's really to solve the use case for like the lowest tech user, right? Mm-hmm. Which is someone who doesn't have a phone, someone who can't receive text, but has a plain old landline phone, right? So what we did was we replaced the entire SMS workflow with automated voice calls, right? And for that, we obviously used a combination of Poly and AWS Connect. And for all of those that don't know, AWS Connect is Amazon's solution for a cloud center in the cloud, which works out great because you don't need to invest upfront in any sort of hardware infrastructure. It's all pay-per-use. So, like Kelly said, right, we bring that startup mentality to solve big problems. Is that we did not need to convince our client to make this big upfront investment to try this out. We just needed one agile sprint to build this out, test it out in UAT, and then boom,
right.
we're in production.
So the service experience is literally the ride arrives at the customer's house, their phone rings, they pick it up, and an auto-generated voice says to them, there's a red Fiat outside waiting to pick you up.
Well, Kabir was nice enough to actually share a demo, so if we want, how about I just play that for you, right? We're going to flip over, and if we're good with audio, let me see if I can play that.
I don't know if we're hearing it.
So it doesn't seem like you're hearing it?
All right,
so we have an issue with audio apparently.
While that comes up, to your point, the interaction, the voice interaction starts a little before that.
Okay, it's fine.
It starts maybe days or weeks before, essentially starts when the appointment is booked, right? So I will call you, and there's a little bit of business logic that sort of takes care of the fact that you actually attend the call, because it's possible you may not be at the house or whatever. So we take care of that, and it tells you that your appointment's been booked to your healthcare provider, so and so date. Car will be there at 4 p.m. So be ready. And then really 20-30 minutes before the appointment is then we start keeping you updated on this is your driver. His name is Ian. He's in a red Fiat. Yep. All those things.
Okay, great.
We can try it again.
Yeah, let's try it with the audio.
And if it doesn't work this time, I'm blaming him, but we'll see.
an automated call from Relay Solutions. Your missed driver, Jamie, has arrived in a white Skoda Octavia with license plate PBO1BC1234 to take you to 620 Atlantic Boulevard. Please meet Jamie outside. You can call Jamie at 91989.
So I'm not going to let the whole thing play, but the sense you get is, you're somebody who is homebound. You set up a ride for an appointment rather than waiting on something high tech, rather than relying on you to use an app. This is something that just calls you and said, hey, look, there's this guy, Jamie, he's driving this vehicle, he's outside waiting for you, here's a number you can call him, and oh, by the way, if you need help, press 1, right? And so what's cool about this is it's using sort of the best of both worlds, right? To this low-tech user, I've got immediate access to services from the provider themselves. They really aren't seeing additional costs to do this, because what they're doing is they're able to get this superior quality of service without having to pay extra for the agent waiting for somebody, right?
What sort of results have you had with this? What's the feedback like from the users of the service? What's the feedback like from your customer? How successful has this been for you? I'm really interested to know what the reaction's been like.
I think it's been immensely successful, right? So we've got three key metrics that we're doing. One is, patient schedule adherence. For this demographic particularly, the number of people that have now gotten to their appointment and gotten to the appointment on time has massively gone up. So, we've only been in production for the last 2-3 weeks. So we've already seen a 10% schedule adherence bump, right? The second thing is rider satisfaction. Now, that's obvious. And we're also trying to figure out a way to sort of capture that through this kind of workflow itself. So we're getting there. So because right now they don't have means to say 5-star, 4 stars, or whatever. So we're trying to automate that as well.
Yep.
And then for
time's been waiting. Estimated time of arrival has been shrinking. So the amount of time spent idle and waiting and that customer experience around just having that extra time and of unknown gaps from all this miscommunication has gone down pretty dramatically.
And then for our client, it's an immediate cost saving. The significant cost saving is because if a taxi does drive up to your house and it's a no-show, you do get charged the cancellation fees. And what we saw in the audit database was, for these kind of patients, there was not just one, but sometimes 2, 3, 4, 5 instances of the same appointment that were canceled. Like $35 a patient, and you're talking about thousands of these rides.
You can quite easily see how that big cost wastage number accumulates over time with that kind of history.
And let's not take away from the fact that a lot of these people are seriously injured, and there's an actual sort of human suffering element
they need
involved.
Treatment.
Yeah.
Great, so we're looking now on the stream at an overall architecture of the system, which includes quite a few different AWS components. And just bear in mind that a lot of the people on the stream are probably new to AWS. So I think it'd be helpful if you could just give a high-level overview of what the different components within the architecture, what purpose they serve in delivering the application that you've described so eloquently.
Sure. All right. We start with the user interface, right? So like I said, we've obviously got, native mobile apps for patients, and then a critical part of it is the web UI, where agents from one call sort of manage and facilitate all of these rides, and all of that is hosted on so we started building this as a monolith, right? Like everything else. Since then, obviously, a lot of customer integrations, hooking up new providers. We've taken more of a microservices approach, which may not be visible in this, but to that sense, a key aspect of providing this facility is having real-time information, right? And for that, we partnered with PubNub, which is also an AWS partner. So PubNub helps us in sort of real-time geo-tracking of rides. It helps us in keeping us updated on what's the latest status of a ride. Did a driver just cancel? Should an agent pick up the phone and do something about it? We have alerts like, if there's a traffic congestion, we'll alert the admin and say, there's a chance that this patient could be late, right?
So there's a couple of things that you're saying that I don't want to lose, right?
Sure.
So one is that you didn't start out with this architecture, that this was something that formed along the way as you learned your lessons. The other thing is that you're talking not just about the building block services, but you're also relying on what partners provide, right? So that's where partners like PubNub will say, okay, you're integrating with Lex, you're integrating with Translate, you're integrating with all of these services that not everybody's familiar with. But what you can do is you can go sort of up the stack, and what that allows you to do as a provider is to essentially provide a better solution without having to drill into every one of those services.
Right.
Exactly.
I mean, and that's been our philosophy ever since, right? We don't want to reinvent any wheels. We just want to leverage what's best in class and provide value to our clients. So, whether it's AWS services or AWS partners like PubNub, I think it's a really good marriage.
Great. So we're almost at the end of the segment, with just a couple of minutes left to go. What do you plan to do next? This sounds like something that's been in production for quite a relatively short period of time. So where are you going to go with this in the future? Do you have other solution areas in mind that you might address with the same kind of approach? What's next for you?
Yeah, we've got actually several, and part of this is the analysis of where are those other human interactions we can replace with something from the ML suite, or other inefficiencies we can take out of the process. So we've looked at a lot of customer data of the operations and the workflow of delivering this service still, and found some interesting kind of areas to attack. Now there's big picture items, but like another small one, a similar case as this is being worked on next, is a significant number of the calls from the call center are focused on confirming arrival at an appointment, because we can track where a patient gets dropped off. And there's a check for quality to make sure that if they're within a certain radius of their intended destination. So there's a lot of, it's like 30% of calls are just checking, did you get there? And the answer is yes. It's confirming a false, false negative. So that's something that we think we can easily kind of replace and automate with the same kind of tools. That is a huge cost savings and value to the patient as well. So that's kind of like next up on the radar.
Excellent. Okay, so we're going to draw to the end of this segment pretty soon. Now, we don't have a whole lot of questions from the stream on Twitch. So is there anything else that you want to cover before we wrap up this segment?
Well, in terms of things that you learned along the way, right? Is there something that you can share? Because again, the audience isn't necessarily AWS experts.
Right.
What would you say is something that people can learn from your experience?
I mean, it's the holy trinity of data usage and impact, really, right? So you got to figure out, looking at your data, once you have usage, on the next place that you make the big impact. So it's an 80-20 thing, right? But at some point, you got to make sure that the solution that you're building is sort of inclusive, and no one really gets left out.
And that's a really important point. The fact that you need to get sort of production data to make good decisions,
right.
But you can't make decisions without that data, and you can't get to production sort of without it. So what you're really saying is, I'm going to take a pass, I'm going to prematurely, to a certain extent, get into production, do a first quick launch, and then see what I can learn once people start actually using it.
This is something that I've noticed in my own usage of Lex. Your assumptions about how customers will use a chatbot or a voice interface, actually they normally don't survive first contact with an actual user. Your assumptions get thrown out of the window, substantially modified, let's say, pretty quickly. And I think one of the things that I really like about the programming model for this service is you can extend and integrate other services together with Lex, together with Connect, to make your applications adaptive. So you can essentially follow the way in which your users end up using your services, not the set of assumptions that you have before you have that first contact with an actual user out in the field or in testing. I don't know whether you agree with that, but certainly something that I've seen in my work with the service.
And you see how much you just think these days you over-engineer everything, you make an app for it, or you just kind of automate it and streamline it in our perfect little bubbles, but then you realize the real world just doesn't work that way. And you're dealing with customer segments that can't use that.
Yeah, I think that's a really interesting takeaway with voice and conversational interfaces generally.
Yeah, so one of the quick data points is, what I've often said to people is, when you build your Lex bot, your first 5 users are going to tell you everything you need to know about what you did wrong, right? When people start interacting with your chatbot is when you...
So true, so true, so true. Okay, I think we are out of time, so we're going to wrap up this segment. I just want to thank our AWS partner guests and our guests from the Amazon Lex team for joining us for this segment. We'll be right back here on twitch.tv/AWS from the summit here in New York in just about 5 minutes. So stay with us and we will see you soon. Goodbye, Twitch.
Thank you.
Thanks.
Bye.